Hello everyone, myself Dr. Veena RS, Associate Professor, Department of ISC, Dayanand Sagar Academy of Technology and Management, Bangalore. Welcome to the lecture video on multi-threaded programming and lab program 11 of object-oriented programming with Java. Subject code BCS306A for third semester under VTU 2022 scheme. So let us see what lab program 11 statement is. Write a program to illustrate creation of threads using runnable. Start method, start each of the newly created thread. Inside the run method, there is a sleep method for suspending the thread for 500 milliseconds. This is what a problem statement that comes under the concept of multi-threaded programming. So before we write a program, let us see what exactly multi-threaded programming is, how to write a multi-threaded programming in Java, and then we will write the problem statement program in Java. What exactly multi-threaded programming? So you can say that the multi-threaded keyword is one of the buzzword of Java. And what is that buzzword talks about is in single program or one single program can have the multiple chunks or multiple parts or multiple sub-programs which can run simultaneously. And that buzzword talks about the concept that is multi-threaded. And this multi-threaded programming is supported by Java. So using Java as a programming language, you can always write a program which supports multi-threaded programming. That means multiple parts of the one single program can be executed simultaneously. We can say, just for an example, if I just talk about the web browser, when you open a web browser, you can see that in one particular tab, you can run one particular URL. Suppose I say gmail.com is one of the tab which I am using URL with. I can also open one more tab and I can give the different, maybe google.com. Or maybe the third tab I can use and I can give some different URL and multiple tabs can run simultaneously. And all these tabs are nothing but the parts of the single web browser. So such type of programming is called as multi-threaded programming. And such programming is supported in Java. So when we talk about multi-threaded programming, multi-threaded program basically contains two or more parts that can run concurrently or simultaneously. We need not wait for one particular part of the program to get completed and then only start the second program. We can have multiple parts of the program, one single program that can run concurrently. That is only multi-threaded programming. And each part of such program is basically known as or basically called as a thread. And each thread defines a separate path of execution. We may have n number of threads, that means n number of parts of one single program, and each particular part will define the separate path of execution. We can say multi-threading is a specialized form of multitasking. So we know that what is multitasking? It is basically doing multiple tasks at the same time. So multi-threading is a specialized form of multitasking. So when we talk about multitasking, there are different types of multitasking. So there are basically two types of multitasking, and those are process-based and thread-based. So process-based type of multitasking and thread-based type of multitasking. So when we talk about process-based type of multitasking, it basically allows two or more programs to run concurrently, and that is not under the control of Java. So process-based type of multitasking, you can say that two different applications are running concurrently. So we can say the example, like suppose we are working in a Java compiler you are using, and at the same time you are using some other text editor also. So this is called as process-based. So two different processes are running at the same time. Two different applications are running at the same time or concurrently. And such type of multitasking is called as process-based. So what is the second type of multitasking we have is thread-based. So what do you mean by thread-based is it allows a single program that can perform two or more tasks simultaneously. And that is definitely under the control of Java. You can write a program in Java in which one single program can perform two or more tasks at the same time, concurrently or simultaneously. So the example for thread-based, you can say that suppose you are using one single application that is the text editor, and you are doing multiple things into that particular one single text editor. Suppose with respect to format, you are dealing with formatting the text, and at the same time you are printing the text as well or printing the document as well. So such type of example or such type of more than one parts to be executed at the same time in the same process or in the same single program program is called as thread-based type of multitasking. So when you talk about process-based, you can say that it basically deals with the entire big picture. Entire big picture is a process-based. And when we talk about thread-based, basically it handles the details about it, the details of the given parts. So this is about types of multitasking. So after knowing multitasking, we should also know that, or we should enter into the concept of thread-based type of multitasking, in which we'll be writing a one single program, and that program will allow two or more parts of it to run simultaneously. And when we say the concept that is multiple parts are executing at the same time or concurrently or simultaneously, you can also call it as a multi-threading or concurrency. So what is the definition for multi-threading or concurrency? We should know. So concurrency is basically the ability to run multiple parts of the program in parallel at the same time. It basically increases the throughput of the program also. Such type of programming is referred to as a concurrent programming or multi-threaded programming. And when we talk about multiple parts of a program are running in parallel, that each part is nothing but the smallest unit of dispatchable code, and that each part is termed as a thread. And it shares the same address space and cooperatively share the same heavyweight process as well. So whenever we talk about threads, multi-threading type of programming will have a smallest unit of code, and that smallest unit of code is termed as a thread. So every thread will have its own call stack and can access the shared data. But when it tries to access the shared data, it may cause two different problems. What are those problems? Are visibility problem or access problem. So we say that there are two threads, suppose A and B thread, and visibility problem basically occurs if a thread A reads a shared data and thread B later changes this data, and thread A is definitely unaware of it. In such case, or that particular problem which is being caused is called as visibility problem. So it's very simple. So when we say one particular program is having multiple parts running parallelly, and those particular parts are suppose having access to one single shared data, one thread is accessing the data or access the data, and the other thread changes it. And the moment other thread changes it, the thread first one which has used that particular data is completely unaware of it. So that problem is called as visibility problem. And one more problem it can cause due to its own call stack is access problem. So what is access problem is, or this access problem can occur if several threads tries to access and share the same shared data at the same time. There are n number of threads, and all n number of threads tries to access the same shared data, and that problem is termed as access problem. So these are the two problems that can be caused due to thread having their own call stack, and they are trying to access the same shared data. Now, when we talk about multi-threaded programming to be written or to be known in Java, we should know what is thread in Java and how you can create it. So threads in Java, when we talk about, there is a separate process will be created for each Java program, within which one default thread called the main thread starts executing the main function. So whenever I say I am writing a program in Java, one program will definitely have a main method, and which will by default gets executed whenever you start executing the program. So separate process will be created for that one default thread, and that thread is called as main thread. And that main thread is responsible to start execution of the main function. So you create one public class. Inside that class, you write public static void main. So the default one thread exists, and that main thread will start executing the main method itself. And the main thread is basically created by JVM. Each thread can be called as an instance of java.lang.thread. So every thread, when you create as a child thread or the main default thread, that thread is basically an object of a thread class. And thread class is basically stored in the package java.lang. That's why we say that each thread is an instance of java.lang.thread. And each thread whenever it is created, will have its name and priority. So every thread can be returned using a name, or you can change the name of a thread also, and you can change the priority of the thread as well. So every thread will have these two properties, that is name of a thread and priority of a thread. And priority of a thread is basically comes into picture whenever we want that any particular subpart that is created will be executed at the earliest or at the last with the least priority, or with the most or highest priority, and all those things. So priority, when we talk about in thread, it ranges from 1 to 10, in which 1 priority thread is always called as the minimum priority and 10 is called as the maximum priority. And by default, if you don't provide any priority to the thread in the program, by default, it takes as 5. That is called as a normal priority of a given thread. And what is this exactly main thread is? This main thread is basically a thread using which other threads can be created. So suppose you want to do a multi-threaded type of programming in Java, you should have one thread which should be able to create multiple child threads. So one single program, that program is divided, or that program is containing two or more parts which are running parallelly. So that 2 or more parts which are running parallelly will be called as the child threads, and these child threads will be created by a parent thread. And that parent thread is nothing but main thread. That is called as a default thread. And the second point which we should know why it is called as main thread, or what is main thread, is it is the last thread to finish the execution because it performs various shutdown operations. As the main thread acting as a parent thread or one default thread which starts the execution of the main function, it can be used to create number of child threads which can run in parallel. And the main thread, being a parent thread or a default thread, will be always the last thread to finish the execution. So in this case, when we talk about multi-threaded programming, the parent thread will be killed only after the child threads. If you do the forceful thread, killing of the child thread or parent thread, that is a secondary issue, but main thread will be the last thread to finish the execution. So when we talk about threads in Java, there are various methods which are predefined methods which you can use it in the program. So the various methods which we can know about is the current thread is one of the method which gets the access to main thread. If I want to know what is the current thread that is running, or what is the main thread details I want to read, it may be the name of that thread or the priority of the thread, I can make use of the method that is current thread. You have a next method named as setName. And if you pass a string type of data as a parameter to this method, it is going to change the name of the thread. Set priority is a method by passing the integer value will change the priority of a thread, and the priority will range from 1 to 10. And if you don't set the priority explicitly, by default, the priority of a thread becomes 5. That is a normal priority. Sleep, and the parameter should be given as of type long, that is in terms of milliseconds, which enters or which makes the particular thread enter in idle state for that particular specified amount of time. So if I say sleep 1000, so 1000 milliseconds, that particular thread is going to enter in the idle state. And after that particular time period, specified time period, it will wake up and it will start its execution again. The next method is getName. GetName basically returns a string type of data which returns the name of the thread. And at the same time, getPriority returns the integer type of data which says it is returning the priority of the thread. So these are some of the methods which we should know to work with a multi-threaded type of programming in Java, like current thread, setName, setPriority, sleep, getName, and getPriority. Suppose I just write a simple program here. So what we have done is we have created a public class here in which we have a public static void main method. That means one default thread will be created that is called as a main thread. And what we are doing here is, you can see here, I have created an object, or I have just given a reference that is object for thread class, that is T. And what T is actually is the current thread. Which is the current thread? That is the default thread or the main thread, you can say. So we can use thread.current thread. So we mean to say that current thread, whenever I'm using with the class name, that means the current thread is a static type of method. So thread.current thread is going to give the access to the current thread. Current thread is which one? The main thread. And that access will be given through which variable or which object is T. And we are trying to print the output value or on the console that with the message, hello, I am a thread. And the value of T should be printed here. So when I say value of T to be printed, it is going to print the current thread details. And what is current thread details is, it will tell what is the name of a thread, that is current thread, what is the priority of that particular thread, and who has created that particular thread. And after that, suppose I want to change the name of a thread, I can always make use of the method that is set name. So if I say t.setName, some new main, so whatever the name before it was there. So before name of the default thread is always main. So now I'm changing the name of that thread to new main. And suppose I'm also changing the priority of a thread with 9. So it was before 5. Now I'm trying to change it to 9. So I can make use of set priority method. And after that, I'll try to print the message like, hello, I am the same thread. That is the value of T should be printed. So before, when it is printing, what are the default values it prints? And after changing the name and priority, what is the new value of a thread printed that we should know? And after that, suppose I want to just print the values, or I just want to print the numbers from 0 to 4. So we can make use of for loop, and I want, after printing or before printing the value of I, we want to make the thread to enter in the idle state, maybe for some particular time. So there can be a delay for executing that thread and going forward with. So we have just written a sleep method here. So sleep method makes a particular thread enter in idle state for specified amount of milliseconds time. So if I have written 1000 milliseconds, it will wait, and then it will wake up and it will start executing the program. Again, the sleep method is of type static. That's why we have made use of the class name dot method name, that is thread dot sleep. And also remember one thing, whenever you are making use of a sleep method in case of multi-threaded type of programming or threading or thread classes and all, that statement can be written only within the try block. If you don't write it in try block, the statement will not, or the program may throw an error. So that's why thread.sleep, we have put it in a try block. So in case there is an exception, it will be able to catch that particular exception. So after that try, what we have written is, we have written a catch method where interrupted exception can be caught here with a message or with the object that is E. And when you say E.print stack trace, it is going to display the description of that particular exception. So if you try to interrupt it, interrupted exception will be thrown and the respective error message will be displayed on the console. So this is a simple program which I have shown it as an example where I have tried to access the current thread, display that. Then try to change the name of a thread, tries to change the priority of a thread and display the new thread, and tries to print some values by giving some particular delay in between. So using sleep method. So I'll just execute this program. I'll show you what will be the output of this program. So you can see here the same program I have written where I have created an object that is T, which is pointing or which is getting the access of the current thread. It is displaying the message with the default values. Then we are changing the name and priority of a thread, printing the values of the new thread or the same thread with the new values, then making use of sleep method to say that there is a delay for going forward, as it makes a thread to enter in the idle state. So as far as this program is concerned, there is only one thread. And one thread is nothing but a main thread or a default thread. We have not created multiple threads here yet. We have just created one single thread. So any program you execute will always have one single thread, that is a default thread or a main thread. I'll run this program. So you can see here when the program is executed, you can see here there is a delay here, and before that it has first display I am a thread. And what is the output of T is, it says this one is the output, that is thread. It says that it is thread, which will have some parameters with it, which says that this first main what you have written, that is called as the name of a thread. As we were using or we were accessing the current thread, the name of thread is nothing but a main thread. What is the priority is 5. And what is the child thread is also main. Or who has created the child, this particular thread is main only. And after that, we have changed the name of the thread and changed the priority of the thread also. And after that, if you print it, you can see here, this is the output being displayed thread, where the name of a thread is new main. What is the priority we have set is 9. And this thread has been created by which thread? That is the main thread. And after that, we have printed the values from 0 to 4. And in between, there was a delay. I will once again execute. Just observe the delay here. You can see after 0, there is a delay, then 1, there is a delay, there is 2, delay, 3, and then 4. And the moment the entire for loop is over, it will come and exit the program. So this is how the program can be accessed for a default thread, and we can make use of the methods which we have listed in the previous slide. So you can see this was the output which we have got it from this particular simple example program. This is not lab program 11. This is a program with respect to the methods to be demonstrated in the multi-threaded programming. After doing that, now suppose I want to create multiple threads there. That means one single program will be running, and that program will have multiple child threads will be executed, and those threads will be executed simultaneously or concurrently or in parallel. So there are two ways to create a thread. One way is by implementing runnable interface. There is a predefined interface named as runnable. You can make use of that runnable interface and you can create a thread. And this particular thread can be created by a parent thread. Any parent thread can create number of child threads. And as runnable is an interface, you cannot extend it for inheritance. In fact, you have to implement it. So that's why we have written as the first way to create a thread by implementing runnable interface. And the second way to create a thread is by extending thread class. So thread class is again a predefined class. We can even extend a class from a thread class, and we can say that that class will act as a thread. That is maybe a child thread or any of the part or smallest unit of code which can run parallelly with the other parts of it. So when I say by implementing runnable interface, you want to create a thread, what are the steps we should follow? What is the first step is you should define a class and implement that class from runnable interface. And runnable interface is basically stored in the package java.lang. And in that class, you should also define a run method. And that run method should have the business logic of the thread in the method. So whatever the logic you want to run it in parallel, that particular logic, you will put it in run method. That run method, you will put it in class, and that class you will implement from runnable interface. And runnable interface is from the package java.lang. This is what the first step you should do. And after this first step is done, you should be able to create a child thread. That means child thread of that particular class or that particular object of the class, and pass the runnable object as a parameter for its constructor. And to start execution, because the business logic of a thread to get executed in parallel is stored in run method. So run method will start executing the moment you invoke start method. And JVM, the moment you invoke a start method, JVM will look for run method of the child thread, and that run method which contains the logic will start executing it. So these are the two steps you should remember whenever you want to deal with or whenever you want to do multi-threaded type of programming using runnable interface. There is a second way as well. Instead of using runnable interface, you can also make use of the thread class and you can create a child thread. So the moment when you say that you want to make use of thread class and create a multi-threaded type of programming, what are the steps you should remember is the first thing is you have whatever the class you want to define it, that should be extended from java.lang.thread. So thread class, as it is a class, you cannot implement it, you have to extend it. Again, define run method and include the business logic of the thread in that particular method. Next, you have to create a child thread by creating an instance of the class. So whatever class you have defined it by extending the thread class, you should create an object of that class. The moment you create an instance or object of that class, it automatically becomes a thread or a child thread, you can say. and invoke a start method to start execution of run method. So when you say there are two ways to create a method, one way by implementing runnable interface, one way by extending thread class, the difference between these steps is if you are using runnable interface, you cannot create an object of runnable interface because it's interface. Interface cannot be instantiated. So you cannot create an object of interface. That's why you have to make use of the runnable type of interface which is implemented, and you have to pass the object of the class as a child thread to be created from the runnable interface. You cannot instantiate directly. And at the same time, if you are making use of extending the thread class, then yes, you can definitely create an object of that particular class and you can start executing the program. So when I say multiple threads to be created, one interface you can create or one thread class you can create and create the multiple objects of the threads, which may be by passing the runnable interface or you can also use a thread class. And whenever you want any particular logic of the respective thread to be executed, that logic should be written in a run method. And that run method will start executing only when you invoke a start method. So these are the things you should remember. So let us see the first way, which actually talks about lab program 11. So you have to deal with or you have to create multiple child threads from the main thread by implementing runnable interface. So that is basically lab program 11. So you have to create multiple threads. So how will you create multiple threads using runnable interface is you will create a class. With what name I want to create a class? Suppose my runnable. And as you have to make use of runnable interface for multi-threaded programming, you will make use of the keyword that is implements followed by the interface that is runnable. And in this class, I have told that you should have a run method stored, which stores the business logic of the particular thread to be executed. So you have written public void run here, and inside run, you will write the statements what you want to deal with. So what we want, suppose it has been told in the problem statement that you have to make use of the sleep method to stop the particular thread to be executed for some specified amount of time and then continue. So inside try block, because I have also already told you that sleep method, you can write it only within the try block. So that's why try block has been used. And suppose I want to display the name of a thread as well on the console, on the output window. So I can just write system.out.print thread started. Whatever the object of my runnable class will be called as thread started. And what is the name of a thread? I want to print it. So first I have to check which is that current thread. So you can make use of the method that is current thread, which can give access to the current thread, which is from thread class. So you can say thread dot current thread dot get name. So first it will check which is the current thread. From that current thread, it will read the name of a thread, and that name of the thread will be displayed along with the message thread started. After that, suppose I want to suspend a thread for 500 milliseconds. So we have written thread.sleep 500. Sleep is a static type of method. That's why we are not making use of the thread object. We are making use of the class name dot sleep method. Then we are writing system.out.println thread ended. And again, while ending the thread, I also want again what is the name of a thread. So again, we have written thread.current thread.getName. So try block, we know that whenever we are dealing with a try block, it should be followed by either catch method or finally block. So we are just using a catch method here. So catch method is going to read the interrupted exception. So if there is any interruption occurs during the try block, that interrupted exception can be thrown and that can handle with the help of catch method. And if it is interrupted, what message it should say? Thread interrupted, and which thread interrupted, the name of the thread also should get displayed on the screen. So this is basically a class called as myRunnable. And this myRunnable class objects can act as now multiple threads. And those threads can run parallelly along with the main thread. So this is what a class implemented from runnable. Then this is what the main class, that is the default thread or main thread, which will get executed whenever you start executing the program. And here we have written a statement like main thread started. And the name of a main thread also got displayed using thread.currentThread.getName. Now, along with this main thread, I want multiple child threads also to get created. So how we can create it? You cannot instantiate a interface that is myRunable because it is an interface. So what you will do, you will have an object with respect to the class that is thread. And that thread constructor will have the object of the class that is myRunable. So you can see here, if you say there is a class myRunable which is implemented from Runable, you can create an object of myRunable class and that can be passed as the thread class. So here you can say one thread, two threads we are trying to create here is thread 1 and thread 2. And thread 1 and thread 2 are nothing but of type thread. They cannot be of type runnable. If that is of type runnable, it is not possible because runnable we cannot instantiate. So that's why what we have done, we have created thread 1 and thread 2 as objects of which class? Thread class. How we will create? New thread. And in this constructor that is in thread, we are making use of what? The myRunable class, which is implemented from Runable interface. And we have not used here the object. We are just using an anonymous object here. So we are not given any name to the object of myRunable class. We are just putting we are just creating an anonymous object and passing it into the constructor of thread. So how many threads we have created now? Two threads, that is thread 1 and thread 2. So the moment we want that thread 1 and thread 2 should start executing parallelly along with the main thread, we will say thread 1 dot start. The moment you say thread 1 dot start, it will start executing the run method of thread 1. Thread 1 is of which type? Thread type. And that thread type is using the object for which class? myRunable class. So it will go to myRunable class. It will search for run method and that method will start executing. Same way, thread 2 is also of the same class, that is myRunable. Again, you are making use of start. So it will start executing run program. Now, suppose we want the particular threads to finish at, we have want to wait for all the threads to be over to carry on with the main thread to be ended. So you can make use of join method. And join method also should be written within a try block. So we have written in try block thread1.join and thread2.join. That means we have to wait for these two threads to finish to continue with the next of the statements. And if there is some interrupted exception in between the we are in between when we are waiting for the threads to finish, it can always throw interrupted exception and we can catch hold of it. And once you can catch, you can just print the message, suppose main thread interrupted, and then you can go forward with the next statement. So once thread 1 and thread 2 are executed completely, it will say that main thread ended and the name of the thread also will get displayed on the screen. So here you can see that in this particular program segment, there are three threads running. One is the main thread, that is the default thread, which has created how many threads? Two threads, that is thread 1 and thread 2. The job of thread 1 and thread 2 is same. Job of thread 1 and thread 2 is exactly same because thread 1 and thread 2 both are dealing with the run method of myRunable class, which is implemented from Runable interface. And there is one more thread, that is a main thread, and job of main thread is something different. So this is how the lab program 11 is basically with respect to the interface, that is Runable interface, how to create the multiple threads and how to run that. So this program basically is not a single threaded, it is multi-threaded type of programming. So if this program we just execute and we'll just see what will be the output of program. I'll take you people to IntelliJ and we'll see how it works. So here I have already copied the program where we have created a class named myRunable, which is implemented from Runable. Then we are having a run method, which we have written the statement like thread has been started, then sleep method and the thread is ended. And then we have created two instances of thread class for myRunable one, and we have started it. The moment you start it, it will start executing the run method. And at the same time, even main thread will be running parallelly, but main thread should be ended only after all the child threads to finish. That's why we have written that thread1.join and thread2.join, which will wait for these threads to complete. It will not continue before that. I'll just run this program. You can see here. First, it says main thread started. The name of the thread is main. Then it says the moment you say thread1.start, it will go to run method. In run method, what is written? Thread started and name of the thread. So what is the name of the thread? Thread 0. What is the name of the thread? Is thread 1. So like this, and in between there is a sleep method also we have used. That means what? It is going to have a delay in between. And after that, thread ended also will come. And only when both the threads have completed, then only it will go for this statement, that is main thread ended. And this is what the output of the program. So this is what the output of the lab program 11, where you have actually created total number of threads as 3. And that's why this thread is called, this program is called as multi-threaded type of programming. So you can see this will be the output of the program, where it has written the first statement as main thread started. Then due to thread 1 start and thread 2 start, it has started executing the run method, and it has executed with respect to the business logic, whatever we have written there. And after that, the last statement, that is main thread, ended. So total 3 threads are running parallelly. 3 threads, that is thread 1, thread 2, and main thread running parallelly. So this is how the multi-threaded programming can be explained or can be demonstrated with the program. And that is basically using the first way to create the thread, that is implementing runnable interface. I hope all of you understood this program and learned the concept of multi-threaded programming as well as lab program 11. So thank you all. So next video will be on lab program 12, which is again the extension of the same concept, that is multi-threaded programming. But in that program, we'll be creating the multiple threads, or multi-threaded programming. We'll do it using the second way of creating a thread, that is class. So thank you all.